Hello and welcome to our third lesson as we look at ways of displaying data. Remember, first chapter, we found ways to collect it, and now we want to display it so that we can use that information to make good decisions and understand a situation a little differently or more accurately. Dot plot, it's a way of representing this data. This is numeric data in this case. Last lesson dealt with categorical, we called it, or qualities, qualitative. This is quantitative, the quantity of something we measure. And in this case, we in class did a times table speed test. Each student did this, and they got different amounts correct. You could have gotten anything from 0 right all the way up to, we had some students get 30 or more, but it was a time test. And the amount of correct is going to be the data, which is numeric, again, not qualitative. And then we're going to count how many times different results occurred for all the students. So a dot plot shows values for each data point. It's going to be one data point gets a dot. And then, we're going to say that it does take a fair amount of time in displaying this because we have to do it one at a time. When we take this data, we're going to a cleaner way maybe to look at things is with a histogram. We're going to count how many there are and then make a bar. It's actually not going to be a bar chart because the bars are going to be next to each other. But that bin of how many students had a certain result is going to be shown in a histogram. We're going to be able to show quite a bit of data. We could have thousands because we can set our scale however we want. In a dot plot, we just count one at a time. The scale is always 1 on the vertical. We're going to be able to see some trends. However, we're going to have to look at how bin widths can be used to better understand the data. All right, so I'm going to make up some numbers here. In my class, students came up to the board as they finished and put dots places. So this is not necessarily accurate, but let's say, a few kids there, a few kids here. All right, so let's say this is our data. We're going to come over to this histogram and, well, I'll explain a little bit here. This, it's fairly important that you understand this idea. This dot represents a frequency, how frequently something occurred. This represents number of questions correct, or number of correct questions. So this is the thing we measured, and this on the vertical, how many dots, is going to be the amount or frequency that result occurred. So when I look at this information, I'm gonna, oh boy, I don't really like the way my numbering came in here. Looks like this could be more accurate. There we go. I must have moved something around. So when I look at the data here, I'll simply count and come over here. So 4, so I want to identify, let's see, 14, so this must be a 15 here. And looking at the way I did my scale here, I'm not real happy about that, but I'm going to count by 2s, I guess. 2, 4, 6, 8, 10, 12, 4, yeah, so we'll count by 2s. And then we'll make our bins next to each other as we do this. And that's all the higher I need to go for the data I created here. Okay, so I'm going to go to 4. I'm going to make a bin at 4 that goes up to 2. Boy, I kind of wish this thing would work differently. 6 has to go up to 4. That doesn't look real straight, but is what it is. Now notice I said that histograms sit next to each other, but it looks like there's spaces in between. That's because this bar height, this bin, is 0 high. So it isn't that I've separated these. We want everything to be next to each other. But in this case, we just didn't have any data value there. I go to 8 and 9. So 8 goes up to 1 and 9 will go up to 1. I will definitely make this look, at least to distinguish between 8 and 9. Maybe even put a 9 there. This is not beautiful, but this is how we make a histogram out of a dot plot. Come over to 12. I need to go up to 3. Boy, I do not like what's happening here, but we're going to get through this. Oh my goodness. Let me erase this. I'm going to go to 3 here and just drop down. All right. And then we're going to skip over to here to 15, and 15 would be somewhere in here, and that goes up 2, 4, 5. And if this is something you already know, I apologize for having you, whoops, watch the mess I'm making here, but the idea is solid. We want to go up to 5 here. And one of the things I suggest to students is once you've found how high they are, go ahead and write the number up on top. And we're going to have much better looking bar graphs, histograms, not bar graphs. Again, this shows us it's a histogram because they're right next to each other. But I suggest you put the count right up on top so you can figure out how many of each shows up. 1, 1, 3, and 5. Okay, so that's how you make a histogram. Hopefully yours will go better. Let's take a look at some of the classwork we did to try to understand some of the things we're looking for here. So unfortunately, this thing is not lined up yet, but I'm doing what I said here. I'll explain the problem here pretty quickly, but I just want to line some things up. Looks like I'm missing my, my 50 here. So I'll just write that in. This is 50 high. All right, let's go through and try to answer some questions, understanding things that we can determine out of a bar graph. So first off, read the title. It's called tree heights. That means we're counting how many trees have these heights. So these are, again, numeric. I don't want to skip over distances along here. If I do that, that relates to one of the kind of problems or misleading things we can have here. So we want the histogram to be solid all the way across. And in this case, it's pretty obvious because we've chosen a bin width that accounts for values from 100 to 150, then 150 to 200. If I did these bin widths by 1, you'd see much smaller bar heights because we'd be counting in a much smaller bin width. So anyway, what is the total frequency? The total frequency, that's this vertical side, is adding up all these bar heights, and that says, let's see here, 80, 108, 112, 122, 123. That seem reasonable? I think it does. There's 123 trees that we measured. And if you look here, if you did this work in class and you had a different number, it looks like we have some room where we're estimating where these numbers are. If they land right where a value can be read cleanly, this should be an accurate number, but this is an estimate, about 123 it looks like. What is the size of each interval? That's the distance of the bin width. So 100 to 150, if you look closely, they have a 50 centimeter bin width. Which interval has the most data? The most data is going to be the highest, and in this case, the 250 to 300. So 250 to 300 is going to be the bin that is most, we found the most values. Which interval has the least? Down here, 100 to 150. How many trees had heights between 200 and 299? Now, this 299, I want to explain. 200, bigger than 200, but not bigger than 300. So 200 to 299 would be a total of, I counted 78. And the reason we put 299 is there's a rule that we'll learn later, but any of the boundary values, if you found an exactly 300 centimeter tree, which bin would you put it in? The rule is you dump it in the bin to the right. So 299, or really 299.99999, is going to be values that are in this bin. As soon as you get to 300, you would start counting the values here. All right, so there's an idea there. Let's take a look at age of attendees for a Chris Rock comedy show. Okay, I'm going to ask you to try this on your own and see what you come up with, and then I will give answers. So you can hit pause. Okay, total frequency. I'm going to go ahead and write my numbers, 2, 4, 4. You don't need me to say these numbers, I guess. And if I add these up, 10, 18, it looks like 20 total people were asked. So the amount of people were 20. Their age is not necessarily 20. That's how frequently we found somebody to ask their age. What is the size of each interval? That's going to be the interval is the horizontal, not the frequency. So the size is going to be this bin width, I called it, and that is 10. And we're going to assume these are years. Oh, that looks like a 5. I'll just put YR. Which interval has the most? That's going to be the highest one, and that interval is the 50 to 60-year-olds. 50 to 60. Which interval has the least? The interval that we just don't even know if anybody could get in if you're under 20, but it looks like the 80 to 90 had nobody. Okay, well, that's the smallest number. 80 to 90-year-olds. How many people attending Chris Rock's comedy shows were less than 40? If they were 40 years old, they went into this bin, so I don't want to count these. So I simply add the 4 and the 2, and there were 6 people under 40 years old. All right, I think I've answered all the questions here. Hopefully that made some sense, and we'll see you in class.